Oh, Frankie. I'll tell you in a minute.
Are you online?
Yeah.
Is it showing your face?
Oh, no. Guess I need to do that. Hi, guys.
You're not in class today?
No, I'm at home.
Were you feeling sick?
Well, I'm quarantined until I get my test results.
Aw, that
Yeah.
sucks.
Yes. So I'll be teaching from home
Okay,
until I know for sure.
sounds about right.
Yeah, not good.
Yeah, you gotta do what you gotta do.
Yeah. And Alyssa, I'm sorry about yesterday, but it should be fixed now.
Yeah, it is. It's fine.
Hey, Alyssa.
We'll have more joining us in a minute. We'll have the whole class on here. So we're going to be looking at the practice problems.
Hopefully, I can find all my stuff. That. I need to go here. Go here. I need to minimize this.
I'll share my screen with you in a minute. And but yeah, you may want to have yours pulled up to look at possibly. How's that?
You're at home.
Yes, I am. I'm having to teach from home. Is that your baby?
This is my baby.
He's so cute.
He's been asleep all morning, so he's
Oh,
just now waking up.
well, he's just in time for Algebra 2.
I know he loves algebra. I think. I don't know. Memphis, do you like algebra? Don't kiss me. Nasty. Yeah, we're remodeling our house. So he rolled in a bunch of drywall mud. So he has chunks of drywall all over him.
Oh, bless his heart. You'll have to
It's
give
okay.
him a bath.
Yeah, whenever I was repainting my room, I did it in like a blue-gray color, and like he literally walked in the pan of paint and literally slipped and nosedived in the paint. So he had blue all over his head. I had to like quickly give him a bath.
Oh, no.
And he is not good with baths. He will literally argue with you and hustle you and fight you because he hates baths. So I'm over here getting my arm gnawed off while trying to scrub him down.
I bet. It looks like he's wanting a lot of attention.
Oh yeah, he's only 2, so he's in that stage of nothing but attention.
Well, we'll have everybody on with us here in a minute. But we're looking at the practice problems is what we're
The ones
doing
that
today.
we did those that Monday,
Yeah, or yeah.
because I turned some in on Classroom and I
Oh, okay. All right. So just pull those up and have those in front of you. I decided I'd work through them today, just to make sure everybody had a good foundation on arithmetic sequences.
because this is kind of the stuff that we did in Bridge last year,
Yes.
or it's the same. So there's some of it like I already understand. And they
Right.
stop.
Hi guys. Everybody's jumping on, so I'm gonna give y'all time to is Zachary Green in class? Can anybody tell me that he's there or not?
The black and white sweater. Okay. And the green jacket back there. Robertson. Okay.
He's not here?
And you? And the one in front of you. And the one in front of you.
Okay, so guys, what y'all need to have out is your practice problems. I know that y'all were working on them yesterday, and that's what we're going to talk about today. So, hi guys.
Hello.
Wait, maybe there was.
Okay, can someone tell the sub that for sure Ramey Womble is absent today? And it looks like Zachary Green is absent. And I haven't seen Haley Wooten on here yet. Oh, There's Raimi. Okay, so Raimi's in class.
Oh my gosh, turn it off.
Okay, never mind. So don't mark Raimi absent because she's on here.
What are we supposed to do?
How do I change my name? It already like had a preset name.
Guys, you need to make sure that what pops up on the screen is who you are.
My camera. My camera. Come here. My camera is broke. Oh my.
Huh?
Okay. All right, everybody got their practice problems pulled up? Okay, I'm gonna share my screen and we're gonna work through this, okay? If you have questions, just put it in the chat, okay? Okay, let me see if I can find it. My cursor's been giving me problems today.
You've been giving me problems.
Okay. Oh, did it erase the whole thing? Where's the,
What'd you do?
all my problems are gone. Let me see. It was there earlier. Okay, let's see. There we go. Okay. Shoo! I thought I had lost my problems. Okay. All right. So, lesson 1, the practice problems, it says, here is a rule to make a list of numbers. Okay, each number is the sum of the previous two. And you were to start with, that's mine.
Mine's over there.
Let's see, let me get over here. It's 0 and 1. Okay, so who has the next sequence of numbers after 0 and 1? You can type it in the chat. Okay. All right. Yes, it is 1. Do you have, Raimi, do you have the whole sequence? Or does anybody want to help her out and type the total of 10 numbers? Okay. All right. That's correct. That would be the correct numbers. 0, 1, 1, 2, 3, 5, 5, 8, 13, 21, and 34. Okay. Now, thank you, Frankie, for, oh yeah, Frankie, you just missed 3s in there, but you got 5, 8. Okay. All right. So let me show you what's going on. Okay. Let me find my pen. Okay. So it's 1 and then 2, 3, 5, 8, 13, 21, and 34. That's correct, because each time what you're doing, if I can find my pen again, okay, you're adding the previous two. Okay, 0 to 1 is 1, 1 to 1 is 2, okay? 2 to 3 would be 5, okay? So the sequence is adding the previous two to get the next one. All right? Let's see, there was something comment in chat. Let me look. I see it. I have it down, but missed it typing it in. Okay, that's fine. That's okay. I do that too. Okay. All right, so moving on to number 2, it says a sequence starts at 1/2, 1/4, 1/8. Was anybody able to figure out the rule? Okay, let's see. All right, times 0.5. That's correct, Caleb. You're multiplying by 1/2, or you could say you're dividing by 2, which is the same as multiplying by 1/2. So yes. Oh, I need to write. Multiply by 1/2. Okay, so that is the correct rule. All right. So what were the next 3 terms that you got in the sequence? Yeah, multiply by 1/2. That's correct. Did someone get the next 3 numbers? Nobody want to type? Okay, here we go. 1/16, 1/32, 1/64. That's correct. So if you took the last one that you had, 1/8, that would give you the 1/16, and then the 1/32, and then the 1/64. So that's correct. Does anybody have questions about 1 or 2 yet? If you don't, that's good. But I mean, if you do, just speak up and I'll help you. Do we have anybody in chat? No. Okay. Oh. Okay. All right. So let's see. We've got, okay. All right. So moving on. Let me get my cursor to work. Okay. It says a sequence of numbers follows this rule. Multiply the previous number by -2 and add 3. Okay, and the 4th term in the sequence is -7. So we talked about this in class, that the rule was -2 times x plus 3. Okay, we talked about the rule, and they told us that the 4th term was -7. And on A, they wanted you to give the next 3 terms. Did someone figure out the next 3 terms? Okay. 17, -31, and 65. Yes, that's correct. So -17, 31, 65. Okay, so what you had to do was take the previous number, multiply it by -2, add 3. Oh, positive 17. Sorry. You're right. I'm getting, I got my signs wrong. Just a second. Positive 17. Let's see. And I can't find my pen. Negative 31, positive 65. Yes. Thank you for pointing out that all right. So now look at letter B. Now we talked about this. Okay, this one up, the rule up above is having it going forward. Let me see what's in the chat. Negative 31, yes. Okay, I did fix that. Okay, so positive 17, negative 31, and 65. Now we got to figure out the first 3 terms. We're going from -7. Okay, so did everyone understand that you do the opposite of what it was originally? So instead of adding 3, you subtract 3 and then divide by -2. Okay, and each time you'll go backwards to the next one. So what did we get in this on letter B? Okay. All right, that's correct. 5, -1, and 2. That's correct. That's what you should have gotten. So 5, -1, and 2. Okay. Did anybody get something different or they don't understand how we got those? Okay. Again, when you're going forward, you follow the rule as it is. But if they want you to find this, going the opposite direction, you do the opposite sign and opposite operation, okay? Except for when it comes to multiply and divide, it stays -2. Okay. All right. So if nobody has questions about that, let's move on to number 4. Okay. So we have a sequence that has 0, 5. You're supposed to give a rule and then the next 3 terms. Someone want to share their answer? Okay. All right. So Andrew, yes, you had it right from previous. Anybody want to share letter A? 4, letter A was 0, 5. What did y'all get in the rule? Okay, x plus 5. So if the rule is x plus 5, and we have 0 and 5, what would be the next 3 terms? Okay, 10, 15, and 20. That's correct. 10, 15, and 20. Now, they say give a different rule for this sequence and find the next 3 terms for that rule. So does someone come up with something different? Okay, so 2 times x plus 5. All right, so again, Okay. Frankie, yours would work too. Frankie has just 5 times x. So he has 0, 5, 25. Whoops. Let's see. 25, 150, and 725. Okay, Caitlin has, let's see. Caitlin had 0, 5, 15, 35, and 75. Is that right? See, yeah, 75. Okay. All right. Anybody struggle with this on these practice problems? Okay. Now, let's go. What I want to do next is I want to go to Google Classroom and I want you to see this video on, let me pull it up. Okay. Everybody stay with me. I'm gonna pull it up. I want us to watch it.
This lesson is all about arithmetic sequences. So to start off, this is an example of an arithmetic sequence, 12, 22, 32, 42. And what makes it arithmetic is the fact that the terms have what's called a common difference. So if I look at how do I turn a 12 into a 22, well, I have to add 10. And I have to add the exact same 10 to turn a 22 into a 32. And then a 32 into a 42, I have to add 10. This number here is called the common difference, and it is what all arithmetic sequences have in common. So if I want to verify that a sequence is arithmetic, what I have to look for is that common difference. It's always the same number every single time. Okay, that's what makes it arithmetic. And this is the common difference, not a common ratio. Geometric sequences have common ratios. Arithmetic ones have common differences. All right, and with these sequences, I can do many things. I can first write a recursive rule for it, just like I do for the geometric ones. I have to have my start with value, which is 12, and then I have to figure out what procedure I have to do to get the next term. So a sub n plus 1 is equal to the previous term, a sub n, and in this case, just a plus 10. So the only difference with these recursive rules is that I just have to change that multiply from the geometric to a plus in an arithmetic one. Now, what's interesting about arithmetic sequences is writing the apparent formula for them. And I'm going to show you a different way of thinking of this sequence that will help you see how to write the apparent formula for an arithmetic sequence. So we're going to start off by rewriting each of these terms. So a sub 1 is 12, a sub 2 is 22, a sub 3 is 32, a sub 4 is 42, right? We know those numbers, but I want to think about where 22 comes from. And 22 comes from me taking the previous term, 12, and adding 10 to it. And then 32 comes from 12, and then I have to add 10 twice to get there. And 42 is 12 plus 10 plus 10 plus 10. Well, what if I asked you for a sub 10? Are you going to write out 10 like that many times, like plus 10 plus 10 plus 10 plus 10? Heck no, that's too much. So what I want to do is I want to think about how can I rewrite this 10 plus 10 plus 10? And I need to think about what repeated addition is. Well, if I repeatedly add the same number over and over again, it's the same thing as a multiplication. So if I look at this, this is really 12 plus 10 times 3. And then I go back and I think, well, this is really 12 plus 10 times 2. And this is really 12 plus 10 times 1. And this first one is really 12 plus 10 times 0. So if I want to figure out what a sub 10 is, I can write all this stuff out if I had the time, but I don't. So I'm going to rewrite it as 12 plus 10 times something, and then I'm just going to follow the pattern. So the first term had a 0, the first term or second term had a 1, the third term had a 2, and the fourth term had a 3. So what's happening with these numbers here is that it's really this subscript number, the little stage number, minus 1. So what goes here is a 9, because that's a 10, so I have to take 1 away, and I get 12 plus 10 times 9. And if I want to go to like some really huge number, like 5,432, I can write all those 10s out. I don't have the time. So I'm going to say 12 plus 10 times, well, what number? Well, it has to be 1 less than this. So it's 5,431. Now, to write the apparent formula, all I need to do is change this into an n. So I have a sub n equals, and then I'm going to do the same thing here. It starts with a 12 plus a 10. And then what do I do to the stage number or the index here to get this number here? Well, subtract 1. So I'm just going to subtract 1 from there. And this is how I write apparent formulas. Now, if you think about an arithmetic sequence, they all work this way. They have some number they start with, and they have some number they add over and over again. And the only thing that changes is this number and that number, but this is going to stay the same every single time. So if I want to come up with a formula to write the apparent formula for any arithmetic sequence, I just have to translate this into the variables. So I know that 12 in this case is a sub 1. So I know that a sub n is going to equal to the first term, a sub 1, plus this 10. Then I need to think about, what is that 10 to the problem? Well, the 10 was the common difference. So I'm going to pick a letter for common difference. I'm going to pick D for difference. So then I put up D there. And then what goes in parentheses? The stage number minus 1. So this thing here is the formula that you would use to write the apparent formula for any arithmetic sequence. First term plus the difference times the stage number minus 1. So let's see this with a couple of other sequences. So let's look at, for example, 55, 48, 41, 34, 27, dot, dot, dot. First, let me verify that it's arithmetic. So to go from 55 to 48, I have to subtract 7, subtract 7, subtract 7, subtract 7. So this is arithmetic. Now, if one of these numbers is off, like if I made a typo or something, and it ends up being like minus 6, then it's not arithmetic and this does not work. These numbers all have to be the same. And since they are, this is our common difference. Our common difference in this example is going to be negative 7. And the sign makes a difference, because if your common difference is positive, your sequence values go up. But these obviously go down, so I have to have a negative common difference. So if I'm going to write the formula for it, it's a sub n equals first term, 55, plus, and then common difference, negative 7, and then n minus 1. And this will give me that sequence if I substitute n for 1, 2, 3, 4, and 5. Okay, now I can also write it like this. I can write 55 minus 7 times n minus 1, because we know that the definition of subtraction is adding the opposite, so I can combine those two signs into just get this sequence here. Let me do another one. This time let's look at a fraction, just to see that you can do this with fractions too. So if I have the sequence negative 1/4, negative 1/2, negative 3/4, negative 1, dot, 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 I can see going from negative 1/4 to negative 1/2, I am subtracting off a fourth, and then I'm subtracting off another fourth, and then I am subtracting off another fourth. So I know it's arithmetic. The common difference is negative 1/4. And so if I want to write the apparent formula, it's start with the first term, which is negative 1/4. I'm going to add the common difference, negative 1/4, and I'm going to subtract, or I'm going to multiply it by n minus 1. So that's the apparent formula for this one. Now, this is not the only way to write an apparent formula. There are many ways to write an apparent formula, and I'm going to show you one other way. And this is how I think of it personally. Whenever I write these rules, this is how I think of them. And I'm going to go back to the very first one, 12, 22, 32, 42, 52, dot, dot, dot. Now, I know this thing has the repeated addition. And I know the shorthand way of writing repeated addition is to multiply. So I know that the apparent formula has to have some 10 times an n. So 10n, I know 10n is part of it, or 10 times n is part of it. But the thing is, that doesn't work. If I think about 10n, 10n by itself generates a 10, 20, and then 30. But if I look at these numbers and I compare them, I see that these numbers are all short by 2. So if I just take this rule and I add 2 to it, I can get the sequences to match up. So I can always take this common difference and take it and multiply it by the n, and then just figure out what I have to add and subtract to make it work. Now, this rule is exactly the same as the other rule, but just not simplified. If I remember what the other rule was I started with 12 and I did 10 times n minus 1. Well, if I follow the order of operations and I simplify this thing to get rid of the parentheses, I multiply 10 times n and I get 10n, and then 10 times negative 1, which is minus 10 plus 12. And if I combine the terms that I can combine a 12 and a negative 10, and what I get is 10n plus 2. So they are the same. It's just this one here hasn't been simplified down. And this one uses the patterns in all arithmetic sequences. And this one, I just kind of have to like try to figure out how it's working.
Okay. So that was just another way to look at the arithmetic sequences. Okay. Let me go back to Google Classroom. Let's see. Well, there we go. Okay. All right. I wanted y'all to see that so that you understand kind of how the sequences can go. For it to be arithmetic or arithmetic sequence, it has to have either a common difference where you add or subtract. And that's what she was pointing out in the video. Let's see. All right. So some of you have logged off. Let's see, who have we lost? Okay. All right. Anyway, going back, looking at Google Classroom. Okay, here's what you need to have done, okay? I think all of you turned in the cool down, but you need to make sure you have the cool down done. Then you need to make sure you get the scavenger hunt done. And the cool down is right down here under Algebra 2. It's right here. Okay, so you need to make sure you have that done. We've gone over the practice problems. All right, we've watched that video today. You need to do the scavenger hunt. All right, now for the rest of the class period, I want you to work on this right here. Here, will you talk to Audrey? Tell her I'm still in class.
Hey, Audrey. It's Chloe.
Anyway, each of you need to do this on your own, this ed puzzle. So what you have to do is click on the link and there will be questions for you to answer as you go through that video. So that's what you need to work on for the remainder of the class period. Okay? Does anybody have questions?
Okay, I will. Bye.
Okay. So nobody has any questions. You know what you need to get done. So I'm going to log out of Zoom. If you have questions or don't understand, you can email me because I will still be here at my computer. But okay. All right. So, all right. You're welcome. And I'll see y'all in tomorrow, probably on Zoom as well. So bring your Chromebooks, bring your workbooks. All right. Thank you so much. Bye-bye.
Audrey said to call her back.
Okay.